Today we're looking at using similar figures to help solve problems. So let's take a look at our first problem here. It mentions that triangle ABC, so this triangle symbol represents that we're talking about this triangle ABC, is similar. So this symbol right here just means similar, and it's similar to triangle DEF in each pair. Okay, so we're supposed to find the unknown length. Now, when we label the triangle ABC, point A corresponds to point D. So these two correspond. So if you look at point A right here, it corresponds to this point here, letter D. And then we have B. B corresponds to E. So this point B corresponds to this point here. So that means this angle here, angle A and angle D, are exactly the same, where angle B and angle E are also exactly the same. And then we have angle C, or point C, I guess, and point F make up the same angle as well. So C and F correspond. So what we're going to end up doing when we use similar figures to help solve for this unknown length, we need to put corresponding sides in the same spot. So for instance, if I'm trying to find X here, I see that AB corresponds to DE. So AB here, 7.5, corresponds to this X. So I'm going to go ahead and set up two ratios, and I'm going to put those units in the same location of the fraction. Since AB and DE are similar, they're not exactly equal, but these are similar figures so that the sides are proportional. So AB and DE I wrote in the same location. And now I'm going to take two other sides. I'll take AC. So AC, so I'm looking at this one here and this one here, that represents 3 meters, and it's proportional. See how A and C are the first and last numbers? Then it's proportional to DF. DF is this one right here. So that's 2. So now we've got our ratio set equal, and we can go ahead and solve the proportion. So the way we solve is just cross multiply. So I'm multiplying 2 times by 7.5. So 2 times 7.5, and then I multiply 3 by x, and it gives me 3x. So now I multiply, and when I do that, doubling 7 gives me 14, and doubling a half gives me 1. So that makes 15 equals 3x. And so all I need to do from that point is divide by 3. And when I do that, I'm left with x equals 5. So that means it's in meters, so I'll just write meters next to the 5. Well, let's take a look at our next problem. And the next one is similar, except this one's a little bit more difficult, because if you look at the triangles, they aren't going the same direction as these were. So it's real important to look at these components here, look at these points, and see which ones correspond. So A and C, or A and B, let's take a look at A and B. These two, 8 inches from A to B, corresponds to DE. So DE is over here. Notice that this triangle is kind of turned around. If we flip it over, if we rotate it, just kind of flip it over C, over this point C, then we'd end up having that same triangle. If I flipped it over this line that I would draw right here, then it would match up perfectly here. So I see A and B and D and E correspond. So I'm going to put those two numbers in the same location of the fraction. Now I'm going to take two others. I'll take the, how about the A and C once more? And it doesn't matter which one you do. I'll just pick A and C for now. So A and C, so the 10 inches, so I'm putting it in the same location, same fraction, same sides, go in the same fraction. And then AC corresponds to DF. See, A and C were both on either ends of naming the triangle, so DF are also corresponding. So D to F would be 15. Now sometimes the triangles look pretty, you can kind of tell which sides correspond, but some of them they're kind of difficult to do, and that's when you'll definitely need to use this concept of looking at the points that make up the triangle, and knowing that the specific order is important. So again, A and D correspond, B and E, and C and F. So now we can go ahead and solve this by, again, cross multiplying. So we're going to multiply the 8 and the 15. So 8 times by 15, and set that equal to 10 multiplied by x, so 10x. And so we'll go ahead and multiply the 8 and the 15, and when I do that, 8 times 5 gives me 40, so I'll carry a 4. So maybe put the 4 right up here. And then do 8 and 1 plus 4 makes 120, and this all equals 10x. And so I can go ahead and divide now, divide by 10, and that'll give me my answer. When you divide by 10, those zeros cancel out. We're just left with 12, so this is 12 inches equals x. So again, notice that you can use any of these sides as long as they're corresponding sides to make this proportion. So you might not exactly do it this way, set it up this way. Could have set up 6 is to 9 as x is to 8, and then we'd end up with the same sort of answer as we ended up with here. So again, 6 to 9 as x is to that 8, and that would give us the same exact answer, just different way to set up the problem. Let's take a look at the next one here, and this here are the two rectangular picture frames that right are similar. What is the height of the larger one? So this is the value we're looking for. I'll call that x. And again, you've got to set up proportions where we have corresponding sides. So lots of ways to set these up, and I'm going to go with the heights, 2 and x. Those are the heights. So I'm going to do height over length, and then I'm going to set up the other one the same way. I'm going to do, let's say, I said height over length, so then I would also set up the other one, height over length. And again, you could do it many different ways as long as you've got corresponding sides in the same location of the fractions. So let's do height to length. So let's do 2 to 3. So I'll do 2 to 3 as x is to 4.2. As x is to 4.2. As long as I'm consistent, I'll get the same answer. And so there's a few different ways to set these up again, but what you should end up having is the x and the 3 being diagonal from each other. So we should always have 3x. And then the same thing over here. I should always multiply the 2 by the 4 2/10. And if I do that, I end up with 8 and 4/10. So now I have to divide 3 into 8 and 4/10. I'll bring the decimal point straight up so I don't forget about that. And 3 into 8 goes 2 times. It makes 6. So I've got 2 left over. And I have 3 into 24 goes 8 times. So there it is. 2 and 8/10 in feet is the set of units I've got. And that's what the height of that larger triangle is. Well, we can solve this next problem. So we don't know the height of this tree, but we see that the shadow that's cast by the sun is 44 feet long. So we can measure that because that's on the ground. Well, let's say we set up a ladder. We know the ladder is exactly 6 feet high because we knew that ladder is measured that high, and we see that we set it up right next to the pine or by the palm tree, and we measure its shadow, and it's 16 feet. So now we can find the height of the palm tree. And so what we're going to do is set up a proportion. Again, last time I set it up with the numbers of one of the figures in one of the ratios. You can set it up that way, but we could also go this way. I could take the two heights, and I can compare those. So I could do the height of the palm tree, let's just say height of tree, over the height of the ladder. And I could compare that to the shadow length. So we'll say shadow of the tree compared to the shadow of the ladder. And that'll give me my same answer. So let's try setting it up that way. Height of the tree, so h over the 6-foot ladder equals the shadow of the tree, and so that's 44 feet, over the 16-foot ladder. And so now we go ahead and cross multiply. So we're multiplying the 6 times the 44 and the h times the 16. So we get 16h equals 6 times by 44. So we go ahead and multiply that 44 by the 6, and 6 and 4 make 24. Carry a 2. 24 once more, but add 2, that makes 26. So now we have to do the division, and we're dividing by 16 on both sides. So I'll go ahead and off to the side do 16 into 264. Well, I know that 16 goes in 26 one time, and I end up with a 16 And I subtract, I get 10 left over. Now I do 104. Now, 16 doesn't go into 104 evenly, but it goes, 6 times 6 makes 90, or 6 times 16 makes 96. And when I do that subtraction, I end up with 80. Well, I have to add a decimal point, carry that 0 down, and I did. And 16 times by 5 makes the 80. And I brought that decimal point straight up so I don't end up making an error. And so our answer is 16.5 feet. And so that's the height of the tree, the approximate height of the tree. Well, those are some problems similar to what you're going to see on tonight's homework. Good luck.